Today we are going to discuss about the relation between specific heats, or it can be find Cp and Cv in terms of adiabatic index, or the question is like that, prove that Cp minus Cv is equal to R. So welcome to my YouTube channel Mechanical Engineering Management. Like, share and subscribe. So the question can be asked in these three different ways. First, consider m kg of mass of a gas is heated at constant volume from T1 to T2. That means temperature T1 to temperature T2. And here I have highlighted this word constant volume process. And you know that for the constant volume process, heat supplied, that is always mc delta T. Here it is constant volume, so it is Cv, that means the specific heat at constant volume. Delta T, that means the temperature difference during the process 1 to 2. As we know that during the constant volume, no external work is done, so that all the heat energy that is utilized to change its internal energy as per the first law of thermodynamics. So I can say du is equal to mCv T2 minus T1. Because of, according to first law of thermodynamics, Q is equal to W plus du. W is the work done. But for the constant volume, no external work, that means W is equal to 0. So Q is equal to du. And so that I can say the change in internal energy, that is exactly equal to the heat supplied. And that's why it is mCv T2 minus T1. Let's say it is equation number 1. Now, second step. Consider m kg of mass of a gas is heated at constant pressure from T1 to T2. This is the highlighted word. I am going to consider now the constant pressure process. In the first part, I have considered the constant volume process. For the constant pressure, you know that heat supplied is once again mc delta T, but this C is the Cp instead of Cv. Cp, that means the specific heat at constant pressure. If I am going to consider the constant volume, then it should be Cv. If I consider constant pressure, then it should be Cp. So when a gas is heated at constant pressure, heat supplied, that means Qp, is utilized for the two purposes. First, to increase the internal energy. That means I can say du is the increased energy, or you can say the change in internal energy. And that you know that always mCv T2 minus T1. And second part is to overcome the external resistance. That means the work done. In case of constant volume, this work done is 0. But in case of constant pressure, some of the heat that is converted into work done. That means utilized to overcome the external resistance. And that work done is equal to P dV, that means change in volume. So simply you can remember the equation W is equal to P dV, heat, that is mc dt, dt that means change in temperature, or you can say delta T. So here you can understand Qp is equal to du plus W. So now I am going to put the value Qp is equal to mCp T2 minus T1 is equal to, as it is, du, that is mCv T2 minus T1, plus W, that is PV2 minus V1. Let's say it is equation number 2. And now I am going to simplify this equation in the next slide. So already we have discussed this equation number 2. Now look at this term, PV2 minus V1. So you know that PV is equal to mRT. So I can say PV2 is equal to mRT2. And PV1 is equal to mRT1. So this is as it is, this is also as it is. But now I am going to put over here PV2 is equal to mRT2 and PV1, that is mRT1. So I can say mRT2 minus T1. So here m is a cancel from both sides. And here T2 minus T1, T2 minus T1, T2 minus T1. So that will be also cancel on both sides. So I can say over here Cp is remaining. So Cp is equal to, here it is cancelled, so Cv plus this is also cancelled, this is also cancelled, so remaining term is R. So I can say Cp minus Cv is equal to R. So let's say it is the equation number 3, and that is known as the Mayer's equation, and that is actually the relation between two specific heat, Cp and Cv. Specific heat at constant pressures and specific heat at constant volume. And that relation you have to remember, Cp minus Cv is equal to R. Now dividing both sides of the equation number 3 by Cv. So I will get Cp by Cv minus as it is, Cv by Cv is equal to as it is, R by Cv. And you know that Cp by Cv is equal to gamma, that means adiabatic index, minus Cv cancels, so that is minus 1, is equal to R by Cv as it is. So from this equation, I can say Cv is equal to R upon gamma minus 1. It is your one of the answer, specific heat in terms of adiabatic index gamma. As we know that Cp by Cv is equal to adiabatic index gamma, so I can write Cp is equal to gamma into Cv. Now I can put this value of Cv in this equation. So it will be Cp is equal to gamma into R upon gamma minus 1. So make a box. So far we have 3 different relations. This is the first answer, derive the equation of Cp minus Cv is equal to R. This is the next answer, find the value of specific heat in terms of adiabatic index, gamma. This is the third answer, specific heat at constant pressure in terms of gamma, that means adiabatic index. I am going to make the box over here also. So thanks my dear friends, press the like button to appreciate this video.